Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to jump into chapter number 8. We're making progress, people, okay? There's only 12 chapters in this book, and we're already on chapter number 8. So we're flying through this book. I know it's a long book, lots of lessons, but you guys are doing great. Keep going, keep pushing forward. Chapter number 8 it starts on page 274, page 274. We're going to be talking in this chapter about radical expressions and equations. What does it mean if something is radical? Well, in math, it means that it has what's called a radical sign. If you look down here at the screen, I put down roots and radicals, and then I put the word radical sign. All right, so what is a radical sign? The radical sign looks like this. So it's kind of like a division sign, but it's got this extra little thing right here. So what is that? Well, it's a radical. What is a radical? A radical is a way of dividing perfect square numbers. So in the last chapter and last few chapters, we've been talking about things like 2 squared. Okay. Now, the opposite of 2 squared, okay, just like the opposite of, and let me use a different color here. So 2 squared. The opposite of 2 squared is this right here, the division. So what's the opposite of 2 times 2? Okay, it's 2 divided by 2, right? The opposite of multiplication is division. What is the opposite of 2 plus 2? Well, 2 minus 2. And then we've been doing that all the way through algebra. That's the way we get rid of something, right? If we want to move something to the other side of the equation, what do? We do the opposite. What's the opposite of multiplication? Division. What's the opposite of addition? Subtraction. And so we've been doing that. We have lots of practice with that. Now we're going to add another opposite. What is the opposite of this? Well, you know that the answer to that, 2 squared, is 4, right? So the opposite of that is the square root of 4. If you take the square root of 4, what comes out of that, or what's divided out of that, is 2. The square root of 4 is 2. Why is that? Because 2 times 2 equals 4. 2 times itself equals 4. That's what that means. The opposite of that is this radical division sign. Now, it's a little bit different than regular division, and that's why they call it a radical. Okay, it's not a division sign. This part right here makes it a radical. Now, there's different parts to the radical. The radical sign, that's this right here. Then there's what's called the radicand. That was the 4. When I put that 4 under there, what's under here is the radicand. If you remember when we did division, if we had just a regular division sign, this thing under here was called do you remember? Okay, the answer is called the quotient. The thing that you're dividing by is called the divisor. Remember this? This was called the dividend. The dividend, okay? And so it's kind of close. Dividend, radicand, they both end in a D. I don't know. You can stretch it and make it work for you, maybe. So if you remember that it's called the dividend, maybe you can remember that this is called the radicand with a D. There's one more thing. So there's the radical sign. There's the radicand. And then there's this thing right here called the index. What is the index? We haven't seen that word before. Well, the index is the number that goes right here. What does that tell us? Here's what it tells us. Remember when we had 2 squared? This index is basically like the exponent right here. Okay. It's telling us what the power is, or what the power was. So in this case, when we have a square root, a 2 goes there. However, typically when we write square roots, we don't write anything. Why not? Because the understood root is a 2. What if this was a 1? Well, what if your exponent was a 1? It's nothing. It just equals 4. So what is this? It's nothing. It just equals 4. Okay? And so we don't ever use that. We don't ever use the 1. We always use a squared. It wouldn't even make sense to put this on there if we were using a 1, so we don't even use it. So in this, if you see that it doesn't have an index, it's an understood 2. Now, these are called square roots with the index. So let me put the index back there. Actually, let me change the index. Let me make it a 3, okay? So now the index is a 3. So radical sign is this thing, the radicand is that number, and the index is that number right there. Okay, make sure you know those 3. Now, what do we call this when there's a 3 here? We call that a cube root. So the squared is the square root. The 3, for the index, is called the cube root. And then if there's a 4 in there, we call it 4th root, 5th root, 6th root, 7th root. There's no fancy names. So square root and cube root. And that's the same as when we square and cube numbers. So that should be easy for you to remember. All right, so those are the main parts, the main pieces, if you will, to the radicals, to these radical numbers, to these roots that we'll be using. Next, I want to show you something, and this is also in your book on page 275, page 275. In your book, you're going to see it's called Table B. What is Table B? Well, Table B lists the perfect squares and cubes. Let's call this the number. Okay? And this is going to be the square. And this is going to be the cube. Okay? So here's the original number, here's the square, and here's the cube. What do I mean by that? Well, take the number 1. So we'll start with the number 1. 1 times 1 equals, you got it, 1. Good job. 1 times 1 times 1 equals, you got it again. Good job, 1. So the number 1, if you notice, it doesn't change. We can keep going with the number 1. Okay? The 4th root of 1 is 1. The 5th root of 1 is 1. The 6th root of 1, it just keeps going. Well, now let's look at the number 2. So the number 2. 2 squared, or 2 times 2, is 4. 2 times 2 times 2 is 8. Now watch this. If I do the square root of 4, I get 2. If I do the cube root of 8, I get 2. That's how this works. Extracting the root means to take it back to the number. What is the number that times itself gives me this other number, this radicand that I have? And you can go through all the different numbers like this. Let's pick another one, the number 7. Okay? 7 times 7 equals 49. That's the square root of 49 is 7. But 7 times 7 times 7 equals 343. You can check that on your calculator just to verify if you want to, but 3 times 3 times 3 equals 343. Now, if I take the cube root of 343, that's going to give me 7. And that's important for you to understand. Now, how many of these do I want you to memorize? This chart that I have on the screen goes through the number 15. In your book, they stop at the number 10. I think what I'm going to do is I'm going to kind of split the difference. Let's go through the number 12. I like that because I think you should know the square of 12 is 144. That's important. Now, I am not going to make you know any of these past 125. Okay? So basically, after you get to 125, you can start using your calculators after that, but you shouldn't need your calculators for the cube of 8, for the cube of 27, and for the cube of 64, or for the cube of 125. Those ones should come pretty naturally to you. You should be able to just kind of, when you see 125 with the cube root, you should be able to think, oh, that's 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. But after that, I'm not going to make you memorize these, and I'm not going to make you memorize these or these. Okay, so Once we get past 12 with the squares, use your calculator. Once we get past 5 with the cubes, you can use your calculators. So there you go. Make sure you memorize those. You can go to the table. And if I was you, I would write in the table in your book, page 275, just goes through the number 10. So I would add the numbers 11 and 12 there. All right, let's keep going. What is the principal square root or the principal root of a number? Let's go to the bottom of page 275. Here's what it is. The bottom of that page shows you, it has this word right here, principal root. And it shows you that what happens when you square root something, and this is interesting. The square root of 4 is actually positive 2 and negative 2. Interesting. What do I mean by that? Here's what I mean by that. 2 times 2 equals 4, okay? But also, negative 2 times negative 2 equals positive 4. Same thing. So when we square root something, technically what we get is we get a positive value and a negative value. Here's the thing for this class, for Algebra 1. Now, we'll make some exceptions to this, and I'll tell you when I'm going to make the exception. But for Algebra 1, we are going to be using the principal root. What does that mean? I only want what this sign, this radical sign right here. What is it? Is it negative or positive? Well, there's no sign, so what does that mean? That means that it's positive. This is a positive square root of 4. The principal root matches the sign of your radical. So what is the answer to this? The answer to this is just positive 2, just the principal root. Okay, unless I tell you I want both roots, I only want you to write the principal root. Don't write plus 2 minus 2. You know, you could write plus minus like this, but I don't want that negative sign. Okay, and like I said, I'll tell you when I want the negative sign. But for right now, in this book where we are, we're only going to use the principal root. Now let me show you something else. What happens when I have a negative square root of 4? Well, my principal root changes now. Now it has to match the sign of the radical. So what is that going to mean? That's going to mean that my answer is going to be negative 2 on this one. Why? Because I solve this, and then whatever sign is waiting for it out there, that's the sign that it gets. So that's what's called the principal root. Okay, principal root. All that means is we're going to attach the sign that's attached to the radical. Now, let me show you something else that's kind of interesting. I can show it to you right here. If I have a negative inside the radical, my negative is inside. Guess what? If it's a square root, there is no way to solve this. This does not have an answer. This would be no solution. Why does it have no solution? Because there's nothing that you can multiply together that's the same that gives you negative 4. You say, yes, there is. I can do 2 times negative 2. Well, 2 and negative 2 are two different answers. You can't do that. That is not root. That is not a square root. Okay? That's not a perfect square. You have to have the same number. You say it is the same number. They're both 2. No. They're different on the number line. One's a positive 2, one's a negative 2. They're very different. If you don't believe that, then you tell me if you would rather have positive $2 or negative $2. Okay? So you understand they're different now, right? You would rather have positive $2. You don't want to owe somebody $2. That's a very different number. Okay? Now, the value from 0, the absolute value is the same, but we're not talking about absolute value here. We're talking about actual value, and they are very different. So you can't, so if you multiply negative 2 times negative 2, that gives you positive 4. That does not give you that. This is not a thing. A negative inside the radical sign, this is not a thing for square roots. We will talk about this later. We have something that we can solve. This is called imaginary, and we'll get to that a little bit later. But for right now, I want you to know that that's not a thing. You can't have that. Now, you can have the negative sign outside. That is a thing. All right, the quotient rule for radicals. The quotient rule for radicals, and then we'll do just kind of practice a few of these, but we'll be done after this. All right, here is what the quotient rule for radicals states. That if you have a fraction underneath the radical sign, we'll call it 4 over 16, and I'll make it something that we can solve out. 4 over 16. Here's what that equals. That equals square root of 4 over square root of 16. And that's important because now you can solve this by saying, what is the square root of 4? Well, it's 2. What is the square root of 16? Well, it's 4. My fraction is 2 over 4. I can reduce that even further, and I can get 1/2 would be my answer. Okay, that's the way that you solve those. Let's do another one. Here's an example in the book. Square root of 49 over 121. Okay, how do I do that? Well, that equals the square root of 49 over the square root of 121. What does that equal? What's the square root of 49? That should come to your mind immediately, okay? I mean, you should think it, and it should just pop into your mind. It's 7. If that doesn't pop into your mind immediately, you need to go back to that table, and you need to memorize those. Over, what's the square root of 121? Again, that should pop in immediately. That's 11. So our answer would be 7 over 11. 7 over 11. Okay? All right. Let's see here. Last thing that I really need to talk to you about is the idea of rational versus irrational. Rational versus irrational. So, rational. Rational means it has a solution. It has, in other words, it makes sense. If something is rational, it makes sense. For instance, the square root of 4 equals 2. That makes sense. Irrational doesn't make sense. The square root of 3 does not exist. There is no such thing as a square root of 3. Now you could say, yes, there is. And if we get out our calculator, I could do 3 square root, and you say, look, 1.7320508. No. That is rounded off. Okay, now that's close to the square root of 3, but that is not a perfect square root of 3. That is what's called irrational because that decimal keeps going. It never ends. It keeps going into infinity. This calculator rounds it off with this last 9, but that number technically goes into infinity. You won't get 3 when you multiply that times itself. Okay? Because it's not a perfect square root. So this was 1.7 whatever it was, blah, 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 blah. This is irrational. Why? Because it ends in a non-terminating decimal. It never stops. This one's rational because it makes sense. It gives us a number. These are the rational squares and cubes. These are the ones that are important for you to know. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144. Those are the ones I need you to know. The cubes are the same. Every other number then is what's on this list. For instance, the number 3, irrational. 5's not in this list, irrational. 12's not on this list, irrational. 15's not on this list, irrational. Every number that's between these numbers is irrational, okay, which means it doesn't have a perfect square. Let me show you one more thing before we end, and then I will be done with this lesson. What happens when we have letters inside of here? So x to the 8th over 4, for example. Well, here's what that equals. It equals the square root of x to the 8th over the square root of 4. Well, we know the square root of 4 is 2, but what is the square root of x to the 8th? Here's what it is. It is what two things, when multiplied together, give me x to the 8th. What two things that are the same? Well, if I multiply x to the 4th times x to the 4th, notice these are the same. What does that give me? X to the 8th. So what is the square root of x to the 8th? It's x to the 4th, because you multiply x to the 4th times x to the 4th. So that solution would be x to the 4th over 2. And that's all you could do to it. You'd be done at that point. Okay? All right, well, that's all I have for you for this lesson. I know there's a bunch in there, a little bit longer lesson, but I really want you to understand this stuff. So I try to take a little bit of extra time in the introduction to this chapter to help you to understand how to do radicals and how to solve them out and how to simplify, how to discuss them, how to talk about them, the different parts, all that good stuff. Okay? If you missed anything, make sure you slide it back and take a look at it. All right, we'll see you later. Have a good one. Bye-bye.